Hey guys, I was just going to go over a few examples for you here. So an ant starts at position 0.37 and moves 9.3 meters left, which means it's going to be negative. Then it goes 1.7 meters to the right, which is positive, 5.2 meters left, and 7.7 meters to the right. If the positive x-axis is to the right, what is the ant's final position? So we're looking for xf. Right, so this is xf equals xi plus d. So this is he starts here, so this is your xi, right? All these other ones are displacements. So then we just plug all this stuff in. 0.37 minus 9.3 plus 1.7 minus 5.2 plus 7.7. Then I put all that into a calculator, and I'll get negative 5.47, and all this stuff is in meters. So that's how you approach that. Let's look at another one. This last one here. A car starts at position of negative 10 and moves to a final position of negative 3. So here we are. This is his xi, right? He starts at negative 10. And then he's going to go all the way to a final position of negative 3. So they want to know, what is this displacement? What is the displacement of the car? So I would solve the equation using math, algebra, right? And solve for d. Those cancel. So displacement is equal to xf minus xi. And that means it's going to be xf is negative 3 minus a negative 10. So you have to make sure you keep the signs. So that's going to turn into negative 3 plus 10, which is a positive 7 kilometers. Let's do one more, I think. Alright, so this one I wanted to go over because this one they're asking for displacement as well, and there's two ways you can find displacement. One way you could do it is add all your displacements together. So you just add up all the displacements. So an ant starts at 2.51. So this is an initial position, but all the movements are displacements. So he goes left, he goes right, he goes left, he goes right. So we're going to add all those up. We don't add the 2.5 because this is a position. So to add up all the displacements, we just do negative 5 plus 1.2 minus 6 plus 1.4. Add them all up and you get negative 8.4. That's meters. Now you could do it another way. There is another way to do it. You can solve for xf first. .5 minus 5 plus 1.2 minus 6 So you do all this just like we would solving for xf, right? So we're not done yet because now we figured out the final position. Now we need to figure out the displacement. So we want to figure out displacement. So just like that last problem, we solve for d. So minus xi minus xi. So we get negative 5.9 minus 2.5. So you get a negative 8.4. So 2 ways to get the same answer. And that's it. Now you could do the rest.